Anyone have any question from last class in EIGRP?
Sir, I have one question. Can you show like how the end operator work for LPM, like longest prefix match? Because
Sorry?
that is the only LPM, longest prefix match. Can you show converting a IP to bit and then using the end operator? How does it
Yeah, let's
compare?
say you have one router here, R1.
So your screen is not visible.
Okay, is it visible now?
Yes, sir.
Yes. So let's suppose I have one router R1. In the routing table of this router, there are some routes. My God. Okay. So let's suppose this router have some route in the routing table like 10.1.0.0/16, and exit interface for this subnet is, let's say, f0/0. Then there is one more subnet 10.1.1.0/24, and exit interface for this subnet is f0/1, and one more subnet 10.0.0.0/24, sorry, /8, and exit interface for this subnet is, let's say, f0/2. Then this is a routing table of router 1. Now let's suppose router 1 is receiving a traffic, right? Let's suppose this router is connected with one LAN and one WAN with internet or with any other router. And now this router is receiving a traffic where destination IP address is 10 dot, destination IP is 10.1.1.1. Destination source is anything, source IP any, destination 10.1.1.1. So router will check what? Destination IP address in the packet. Then router will compare destination IP address with their routing table. So guys, in the routing table, 3 routes are available, and destination IP address is matching on in all the routes. Yes or no? Now router need to find which one is the best. How it will find which one is the best? For that it will check network bits. In which route longest network bits are matching, right?
Yes.
So see guys, value in first octet is what? 10. Value in first octet is 10, means first 8 bits value, first 8 bit value is 10. And in the routing table there are 3 routes with same value in first octet, correct? 10, 10, 10. That means first octet is matching in all subnet, first octet. Then second octet, so in second octet value is 1, right? Okay, in this route also in second octet value is 1. In this subnet also second octet value is 1, but in this subnet you can see value is 0, right? So that means this destination IP address and this subnet and this destination IP address, you can say 8 bits are matching, 8 network bits are matching, and these two subnets are matching over here. In these two subnet means in these two subnets 16 bits are matching, even more than 16 bits are matching in this subnet, right? Here, because the third octet value is 1, and here also in third octet value is 1. So where longest network bits is matching in this subnet? How many bits is matching? 24 bits. How many bits is matching? How many network bits is matching over here in this subnet? 8. How many network bits is matching in this subnet? 16. How many bits is matching in this middle subnet? 24. So 24 is going to be best. Router will exit traffic from f0/1. Now in the same way, let's say in the routing table of router we have routes like this, not like this. let's say 10 dot 10.1.1.0/25 f0/0, then 10.1.1.128 will be the second subnet. If you know the subnetting, f0/1 is the exit interface for this subnet /25. Got it? Now again, destination IP 10.1.1.1 on router will receive the traffic. It will compare destination IP with routing table. In the routing table, now tell me where longest prefix match is, longest network bits is matching. In first subnet from 0/0 or from 0/1?
0/0.
0/0.
0/0.
Yes.
Yes.
Where the bits is not matching? Where bits is not matching? On which bits? At which position bits is not matching? First bits is not matching. See, if you will convert it into binary, like your IP address in the packet, destination IP address, and the route in the routing table. So even to check, we don't need to convert these value in binary. The reason, guys, these values are exactly same in both subnet. First 3 octet is matching in both subnet, right? So if you will convert last octet of IP address in binary, then it will be 7 times 0 and last one, right? If you will convert these routes in the routing, like the route of routing table in binary, so what will be the binary of first subnet? All 0. All 0, 2, 4, 6, 8. And binary of second subnet is going to be what, guys? 1.0000000, right? So now you
Yes.
can compare this IP address, this is the destination IP address, and this is the routing table, right? In second subnet, you can see value is first bit in fourth octet is 1, and first bit in the packet is 0. It's not matching, right? That means only 24 network bits is matching in this subnet. But if I will talk about this upper subnet, so you can see 31 bits is matching. Correct? Is it clear now, bro?
Yes, sir. Now it's clear.
Right, so that's why it will forward traffic from f0/0, not from 0/1. This is very important. This is how router perform best path selection. Any other question, guys, from the last class? What we have covered in last class? What is EIGRP? If I will talk about the types of routing protocol, see guys, EIGRP is a very important routing protocol for exam also, for job also, like for interview. Even if you will go for the CCIE lab exam, right, you will see lots of questions from the EIGRP there. So it's very important to learn each and every topic very carefully, right? All the topics should be very clear and crystal to you. So if I will talk about the types of routing protocol, or if interviewer is asking you which type of routing protocol is EIGRP, what will your answer?
It's an advanced distance vector protocol.
Advanced distance routing protocol.
Yeah, we can say hybrid routing protocol, right? Means combination of distance vector plus link state. EIGRP uses some properties of distance vector routing protocol and some properties of
Link state.
link state routing protocol, right? You know the properties of distance vector routing protocol, like sending periodic update, using hop count to calculate metric, right? There is no neighborship, and link state, which maintain 3 tables: neighbor table, database, routing table, which send partial and trigger update, which calculate metric on the properties of link,
Properties.
right? And by default, EIGRP uses which k values for metric calculation?
Bandwidth.
K1 and K3.
K1 and K3 it uses. Bandwidth and delay.
Yes, Saurabh, go ahead.
Sir, the lab that you were performing on GNS3,
Yeah.
the values that you are getting on GNS3 now, when I'm performing the same over the packet tracer, I am not getting the same. Like in router EIGRP, you mentioned for network 000 and it taken all the interfaces. But when I am trying to do it on packet tracer, it is not taking the commands. So, any issue with the software
No,
or
no, no,
means?
no. It will work in packet tracer also. I will show you. Okay. I will show you. Don't worry.
Okay.
I will show you. See, let me do one thing. Let me open the packet tracer also side by side.
Because I have also done it on the lab in my laptop.
Okay, might be possible there is some error on the specific router, but in packet tracer it's working. I have configured many time EIGRP in packet tracer.
2811 series I have taken router.
Okay, now I have packet tracer also. We'll check here. First, let me discuss, guys. Let me discuss the previous class. After that, I will come on your point. We'll see. We'll run network 0.0.0 command in packet tracer also. Okay. So in last class, we had seen types of routing protocol. This routing protocol is an advanced distance vector routing protocol or a hybrid routing protocol, right? Which algorithm this routing protocol uses to calculate metric? It uses dual algorithm. Dual algorithm stands for diffusing update algorithm. Means first EIGRP will establish neighbor with the help of hello message. Once it will discover the neighbor, it will form the adjacency. Both routers are going to exchange update message. Both routers will learn routes of each other. It will store that routes in the topology table. On the topology table, routers will run dual algorithm and it will find best path with the help of FD, with the help of RD, feasible distance, reported distance, successor, and feasible successor. Right, so these are the terminology of dual algorithm. Right. For the metric calculation, EIGRP uses k values and we have 5 k values. By default, it uses k1 and
K1 and
k3.
K3.
And you know the reason also, like why by default it uses only k1 and k3. What is the benefit, guys? These are the,
It fixed values.
yes, these are the fixed components. You can use reliability also, load also, but in that case your metric of EIGRP will be changing, keep changing. Sorry. So that's why we should use fixed value for the metric calculation. We'll see how we can change the k values. Like if you want to use k3 also, sorry, k2 also, or k4 also, k5 also, you can, right? There is command. Then what we had covered, types of message, right? So how two routers will become neighbor, guys, in EIGRP? With the help of hello message. Once you will enable EIGRP on router, how you will enable EIGRP on router? By running command router EIGRP and then ES number. Always keep in mind EIGRP works within autonomous system number. Two router can form neighbor adjacency if both belongs to same ES. So k values and ES number are the neighborship parameter in EIGRP. These two must be same. Then only two routers will become neighbor. Right? Purpose of hello message: discovering neighbor, searching neighbor on particular interface, and then maintaining the neighbor, keep alive. So once I will run router EIGRP ES number 100, my router is going to allocate some memory to EIGRP routing protocol. and after that, with the help of network command, we are going to advertise the network, or you can say we are going to enable EIGRP on interface. Let's say I'm running 10.1.1.0/24 or 0.0.255. So once I will run this command, router will check this network is running on which interface, right? Let's say this network is running on F0/0 interface. So router is going to enable EIGRP on F0/0 interface. Once it will enable EIGRP on F0/0, it will start sending hello message from that interface. If this is the LAN interface, then we have to stop the hello message. So what we can do, we can configure the passive interface. We can configure passive interface, right? Then once router will receive hello message on EIGRP enabled interface, it will check parameters like the autonomous system number and k values. K values means whatever k values I am using to calculate metric, my neighbor should also use same k values, right? This is not like bandwidth should match or delay should match. If I'm using bandwidth and delay to calculate metric, then my neighbor should also use bandwidth and delay, right? We had seen the hello time, hold on time. After that, we had seen the metric calculation also. Metric calculation. Formula is 10⁻⁷ upon least bandwidth plus total delay upon 10 whole multiplied by 256, right? So least bandwidth means bandwidth which is coming in update and my receiving interface bandwidth. If the network is directly connected, then it will not compare. It will directly use the bandwidth of the interface where the network is connected. Then guys, we had seen once EIGRP router will form neighborship adjacency, router will send update message. Update message. Which update message first? First it will send null update message. What is the purpose of null update message? Purpose of null update message is checking bidirectional connectivity, that there is bidirectional connectivity or not. With the help of null update message, EIGRP routers also exchange sequence number with each other. And guys, today I am going to tell you one more thing, one more use of null update message. One, bidirectional connectivity. Second, exchanging sequence number. And third, in last class we had seen some timer in the neighbor table, SRTT time. We had seen RTO time. So router is going to calculate these timers also with the help of null update message only. Actually, you know what is SRTT time? SRTT time is nothing but the amount of time in millisecond that a router takes to receive acknowledgement message. You know, EIGRP is a completely reliable routing protocol. Some messages are reliable, some messages are not reliable. Hello message is not reliable, but update, query and reply, these three messages are reliable. And for the reliability, EIGRP uses third protocol, that is RTP protocol, right? So guys, let's say I have two router 1, router 2. Between router 1 and router 2, I have one subnet 12.1.1.0, let's say R1, R2. Here I have subnet 12.1.1.0/24. Router 1 is connected with one LAN 10.1.1.0/24. R2 is also connected with one LAN 20.1.1.0/24. Right? So how these routers are going to exchange this network information? First, it will form neighborship. right, with the help of hello message. Both routers are going to send hello message to each other. In the hello message, both routers will share what? Their autonomous system number, their key values, hello time, hold on time, version information will be there, opcode will be there, means types of message, and ons parameter will match. Both router will become neighbor. Both router will become neighbor. Once both router will become neighbor, routers are going to exchange what? Routers are going to exchange null update message, right? Router 1 will send null update message, and you know update message is an reliable message. So let's say this is null update message of router 1, null update. Fine. So once router 2 will receive this null update message, router 2 have to generate acknowledgement. Router 2 have to acknowledge router 1, right? So let's say router 2 have sent the acknowledgement, and router 1 have received the acknowledgement of their null update message after 40 millisecond. For an example, acknowledgement. After 40 millisecond, router 1 have received this acknowledgement message. So guys, SRTT time will become what? 40 second. So what is SRTT time? It is very important for interview. Interviewer can ask you this question. You can say amount of time in millisecond that router takes to receive acknowledgement. And router calculate SRTT time with the help of null update message only. Means now router 1 knows that whenever I will send any update message to router number 2, I can expect acknowledgement within 40 millisecond, right? This is the, you can say, delay for this particular neighbor, right? And after that, router is going to multiply some value with this timer, and then it will calculate RTO time. RTO time. RTO time is nothing but the retransmission packet. Retransmission packet back, you can say. Like whenever router will not receive acknowledgement, router will retransmit the update message. Now let's say both router have exchanged the null update message, right? Both routers have the sequence number. Both routers have calculated SRTT time for their neighbor. Now guys, routers are going to exchange actual network information, right? Actual network information. So router 1 is going to generate update message. Router 2 will also generate update message. So let's suppose router 1 is sending the actual update message to router 2. In the actual update message, it will carry network information. Which network information? 10.1.1.0/24. Will it include 2L network in update? Will router 1 include 2L network, guys? Always keep in mind, this is not the behavior of
Directly
EIGRP.
connected.
This is behavior of all routing protocol, right? All protocol is going to not include the subnet which is running on exit interface, from where router is sending the update, right? So 2L network is running on exit interface, so it will not include 2L subnet here, right? This is update message. Update message. Now it have sent to router number 2. Let's say because of congestion on the link between router 1 and router 2, or due to any reason, let's say someone have configured the filtering on router number 2, right? Or router 2 have received this update message, but it have not generated the acknowledgement. Or router 2 have generated the acknowledgement, but because of congestion on the link, router 1 have not received the acknowledgement. Then what will happen? Then there is issue. Because router 1 have sent the update message, router 1 should receive acknowledgement for this, but router 1 have not received any acknowledgement. So guys, router 1 will retransmit the update message, and this time update message will be unicast, not multicast. This update message is multicast. Multicast, right? It will wait for acknowledgement till SRTT time, because router know how much time their neighbor takes to give acknowledgement, it will wait for the acknowledgement till 40 seconds. After 40 seconds, if router within 40 seconds, if router 1 will not receive the update message, router 1 is going to retransmit this update message, retransmit, right? But this time it will send on unicast address. Why on unicast address? Soon you will understand that also, don't worry, right? This time it is unicast. It is unicast. Unicast. It will forward to their neighbor only. Guys, the reason of unicast is, let's suppose topology is hub and spoke. You all know hub and spoke topology. Hub and spoke topology means all the branch offices are connected with hub router. Let's say this is my headquarter data center in India, R1, right? And I have some branches in, let's say, US, R2. One is in, let's say, Australia, R3, right? And all branches are connected through internet, right? Here you are running EIGRP routing protocol between all the sites. So router 1 will have two neighbor, router 2 as well as router 3. Let's say router 1 have one subnet here, X subnet. Router 1 will generate update message to share this X network information to their neighbor. It will forward to router 2 also, to router 3 also. Now router 1 is expecting acknowledgement. Let's say router 2 have acknowledged. Router 1 have received the acknowledgement from router number 2, but it have not received acknowledgement from router number 3. So router 1 will send unicast update message to router number 3 only, not router 2. But if it will send on multicast, then both router will receive, correct? So that's why second message is unicast, right? Sequence number is going to be same, right? Let's say here sequence number is 1 in the update message. So here also sequence number is going to be same. That means there is no any updated information in the update message. This is just because I have not received your acknowledgement. That's it, right? Now it have sent the unicast update message. After that also,
Right.
if router 1 have not received the acknowledgement, then it will again send one unicast update message with same sequence number. After what time? After RTO time, retransmission time, retransmission timeout, right? So till when router 1 will wait for the acknowledgement of this unicast message? Till RTO time, that is RTO, right? So hope SRTT and RTO both timers are clear. Then guys, what we had discussed else, we had covered the query message, update message, hello message, then third message is query message. What is the purpose of query message? Purpose of query message.
If successor goes down, then it will take the other path.
Okay.
Means if a successor is down and no other path is there, then it will generate a query message.
Okay, fine.
Root
For the
root
multicast
What is the purpose of
purpose.
query message? Try to understand my question. Purpose of query message.
root positioning plus
That
alternate
there
route.
is no alternate route is there to transmit a message. That's the purpose of
First
query
purpose is
message.
to inform neighbor that, bro, neighbor, if you have learned this submit via me, then uninstall it from your table, right? And second purpose is, if you have alternate path, then send to me also. This is the purpose of query message. And query is, guys, also reliable
Reliable.
message. Means whenever router 1 will send query message to router 2, router 1 will expect two messages, one reply message and second acknowledgement message, right? Router 1 will expect two messages from router number 2 from their neighbor, one acknowledgement and second message is reply message, right? So we have query, reply and then acknowledgement. So these are the messages of EIGRP. Multicast address is 224.0.0.10. So once you will enable EIGRP on any interface, first thing that router will do is it will join the multicast group 224.0.0.10. Now, you know, sometime interviewer can ask you questions like at which layer EIGRP will generate their hello message. So guys, EIGRP is a network layer protocol, so definitely it will generate their hello message at layer 3. They can ask you what will be the information inside hello message, right? What header router will encapsulate? So router will encapsulate IP header and Ethernet header. Layer 3 header and layer 2 header, right? Means just they are trying to check your knowledge about packet flow in EIGRP, right? Like we have enabled EIGRP on router 1 and router 2, how packet flow will be there, right? So both routers are going to encapsulate, generate hello message at layer 3. Then EIGRP will hand over to IP protocol. IP protocol will add source IP, destination IP, which will be multicast, and the protocol value of EIGRP is 88. Then IP protocol will hand over it to lower layer, data link layer. Data link layer will add source MAC, destination MAC, which will be again multicast, and the type code of IPv4. This is the encapsulation of hello message. In the same way, it will encapsulate update message also, query message also, reply message also, acknowledgement message also, right? And guys, let's suppose you have configured the EIGRP on router number 1. You have configured the EIGRP on router number 1, but you have not advertised any interface. Then will router generate any hello message? Answer is no. No, because routing protocols works on interface of router, not on router. And whenever router will receive any hello message of EIGRP at layer 2, it will verify that this message is for me or not with the help of multicast group. Then by default EIGRP support how many hops? 100. We have seen this all thing in the output of so IP protocol. So IP protocol hop count. We can configure up to 255. Maximum path was 4, I think, by default, right? Automatic summarization was enabled or disabled? No auto summary.
It's disabled.
Automatic
Disable.
summarization was disabled. That means this command was enabled. Summary. No auto summary command is enabled by default. EIGRP is a classless IGP protocol which works within the ES. These are the definition whenever someone is asking you what is EIGRP, right? So hope these all basic points are clear to everyone. Successor, feasible successor, dual algorithm, hello message, update message, query message, reply message, acknowledgement, neighborship adjacency, null update message, SRTT time, RTO time, right? Metric calculation, K values. Done, guys? What is reported time? What is the difference between FD and RD?
Distance
To
between source
destination
and
neighbor.
destination, FD.
Total metric value from source to destination and from neighbor to destination.
neighbor to destination
Yeah,
right.
reported is from neighbor to
Neighbor to
destination.
destination.
Correct. And FD is from source to destination. What is
Source to
feasibility
destination.
condition? What is feasibility condition? If there are two paths between source and destination, like in this topology, you can see this is my, let's say, source, this is the destination. So between source and destination, how many paths are available? 2. Let's say upper path is the best path, successor. Will lower path become feasible successor? For that there is one feasibility condition. What is the feasibility condition?
That the reported distance should be less than feasible
RD
distance.
should be less than FD of successor.
FD is greater than RD, should be greater than AD of RD.
Yes. Okay. Then there is one concept of variance also for unequal cost load balancing. Like we can see if metric is not equal on both path, then also we can achieve load balancing. And EIGRP is the only protocol in entire world which support this feature, unequal cost load balancing. There is no any other routing protocol except EIGRP who can perform unequal cost load balancing. Means if matrix is not equal, then also EIGRP can perform load balancing. Except EIGRP, it is not possible in any other routing protocol. So we have concept of variance there. Concept of variance. So now we have the variance concept, we have the redistribution concept, we have some advanced concept of EIGRP, right? And we'll definitely see those things like how to change hello timer, hold on timer also. Like let me show you here on R1. If I will access R1, here config T, and then you can change hello timer on interface basis. Let's say on F0/0 I can say IP hello, IP hello interval for EIGRP S number 10, and after that whatever time you want to configure, right? In the same way IP hold on time for EIGRP S number 10, like this. Passive interface, router EIGRP S number 10 and then passive interface. So your all LAN interface should be configured as passive, like F1/1 is my LAN interface. So this interface should be configured as passive. Then there is concept of stub. We'll see that also. Okay, so let's begin. Let me do one thing. First of all, I am going to enable EIGRP here in this topology. Let me access all the routers R1, R2, R3, R4. From R1 router EIGRP S number 10 and network 0.0.0, right? Do so history. Let me copy the command and I'm going to paste this command on all the router. And guys, how to verify the EIGRP enabled interface on router number 1 now? IP EIGRP interfaces, right? This command will show you all EIGRP enabled interface. So see, EIGRP is enabled on F0/0, F1/0, loopback 1, loopback 2, loopback 3, 4, 5. Done. On all the interfaces EIGRP is enabled. And now router 1 is sending hello message, debug IP EIGRP, debug EIGRP packet hello. These are the troubleshooting command we are using while troubleshooting EIGRP neighborship, route flapping. You will see multiple types of issues can come. See, it is sending hello message from F0/0. From all the interface it will send hello message. In the same way you can enable debugging for update message also. And to stop hello message on loopback interface, I can say router EIGRP S number 10 and passive interface loopback 1, loopback 2, loopback 3 and loopback 4, loopback 5. Done. Now let me take you to router 2, and before moving to router 2, so IP protocol is the most useful troubleshooting command for all the routing protocol, right? The first troubleshooting command of routing protocol is so IP protocol only, right? First information that it will give you is the routing protocol. It can be RIP, it can be EIGRP, it can be OSPF, it can be BGP. Then same information you will get in OSPF also, the filtering for outgoing traffic and incoming traffic. In EIGRP we are going to master the filtering. After that, autonomous system number, K values, K1 is 1, K2 is 0, K3 is also 1, K4, K5 are 0. Hello time and hold on time. Router ID, distance, maximum path, maximum hop count, Variance value is by default 1. We will discuss about it. Automatic summarization is disable. And routing for 0.0.0 means for all the subnets. That's it. Now let me enable EIGRP on router 2. So router EIGRP is number 10 and I am saying network 0.0.0.0. Do so history. And you can see the neighborship EIGRP neighborship. Guys, if you are not able to read this log message, don't worry. We will have one session for syslog, right? How to read this log message. But from here you can read at least. It is the message of EIGRP. Whenever you will perform any task on router, router will generate a message for that task. Right? So this message is for EIGRP IPv4 autonomous system number 10. It is about the neighborship. About the neighborship. Neighbor IP 12.1 on which interface on F0/0 is up and new adjacency formed. Right? Now let me copy this command router EIGRP and network 0.0 and let me paste it on R3 also, on R4 also. And on router number 4 we are going to configure passive interface loopback 1, loopback 2, loopback 3, passive interface loopback 1, loopback 2. I think loopbacks are not there, so IP interface brief. Yes, loopbacks are not there. Let me create the loopbacks. Interface loopback 1 IP address 192.168.1.1 255.255.255.0. And guys, it will be better to use notepad to configure the devices. In notepad you can write down the command and after that you can copy and paste it. So on loopback 3 interface I am going to configure 3.1. On loopback 2 interface I am going to configure 2.1. Loopback 4 I am going to configure 4.1. And on loopback 5 I'm going to configure 5.1. Done. Now so IP EIGRP interface. So EIGRP is enabled. Now we can disable messages of EIGRP on LAN interface. So router EIGRP as number 10 and say passive interface loopback 1, loopback 2, loopback 3, loopback 4 and loopback 5. That's it. Done. Now my EIGRP topology is stable and all routers are able to communicate with each other. Like these two sides can communicate with each other. So IP EIGRP neighbor. So router 4 have two neighbor. What is SRTT time? 700 millisecond for this neighbor and 697 millisecond for router number 2. Right? And for both neighbor it have calculated what RTO time. RTO time is nothing but multiplier of SRTT time. And then there is something called Q count here. So guys, what I told you, whenever router will not receive acknowledgement message of update message, it will send same update message on unicast address with same sequence number. And whenever router is waiting for the acknowledgement, whenever router will send unicast update message and is waiting for the acknowledgement, that time it will increase Q count by 1. So if Q count is 1, that means your EIGRP neighbor table is not stable. Neighbor table is not stable. And from this particular neighbor, this router have received updated information with sequence number 15. Right? And from this neighbor, sequence number 16. So for both neighbor there is sequence number, Q count, RTO time, SRTT time, uptime. Uptime means till when neighbor is up. Then hold on time means after 12 seconds it is going to flush this neighbor. It is going to remove this neighbor from the table. But this timer will be resetting after every 5 seconds because the hello time is 5 seconds. Routers are exchanging hello message after 5 seconds. Then interface is there and the neighbor IP address is there. Is there anyone who is not able to read the output? Here also on all the devices you have same output. Clear, guys? Sometimes interviewer can ask you the content as well, like what is the content of hello message in EIGRP. So you can capture the link and you can check the message once, right? Like you should have the basic idea about the content. Like in hello message, router is going to share ES number, opcode means types of message, version, then you can say key values, right?
A values without parameter.
Key values without
Parameters.
which parameters?
Parameters like what means what the bandwidth is,
No, that is
what
the
the
part of
delay is.
update message.
Yes, sir,
See,
that's out
the
of
parameters like the bandwidth value or delay value is required for the network, right? Hello message is used to discover the neighbor and to maintain the neighbor. So why hello message will carry network information? 255.0.0.0. Here I have configured this submit. And now bro, see I am running router EIGRP, yes number 10 and network 0.0.0.0. So command is working, right? So IP EIGRP interfaces. You can see EIGRP is enabled on F0/0. So it's working fine in packet tracer also. Can you tell me the series of your router? Sort of
2811.
2811. Yeah, I am using same one here. This command is working, so you can check again.
Because when I enable network 000, it should enable EIGRP on both interfaces, no?
Yeah,
That's
it
the
will
thing.
enable EIGRP, but this interface is down na.
Means both
F0/1
the
is down. You have not configured any IP address there. So guys, if IP address is not configured on the interface of router, router cannot enable EIGRP, even not any routing protocol, not any routing, even not you can say routing protocol, not any protocol, until and unless IP is not configured there, right? Because all the layer 3 protocols work on IPv4 protocol only. So until and unless you will not configure the IP protocol, that means the main family is disabled. EIGRP is what? Network layer protocol works on IPv4 network. So if interface don't have the IP address, that means IPv4 service is not enabled here, right? Let me close the packet tracer. You can perform the lab in packet tracer also. It will work. It will work exactly same like GNS3, EVNG, doesn't matter where you are doing the lab. And guys, router will send how many hello messages? Router will send 16 unicast, update messages. If router will not receive acknowledgement of update, then router will send total 16 number of unicast update messages. After that, it will break the neighborship. After 16 unicast update messages, router will break the neighborship. And these all things like the breaking neighborship, unicast update message, RTO time, SRTT time, these all concepts are connected with each other, right? So keep in mind the flow, that whenever router will send update message, router should receive acknowledgement. If it will not receive acknowledgement, it will send same update message on unicast address with same sequence number, right? If it will not receive acknowledgement, it will again send the unicast message after RTO time. It will send 16 number of unicast update message. After that, router will break the neighborship.
and sir, if it will not receive any acknowledgement, then queue count will increase one by one.
Q count will be 1.
Okay, means if at first time it doesn't receive, then queue count become one.
Yes,
And second time also, if we
one only.
even at unicast also.
Yes.
Okay.
Now here we can check the routing table. So IP route EIGRP. So you can see I'm learning all 192 prefixes. I'm learning all 192 prefixes here, and router is doing what? Load balancing. It have installed both path in their routing table. Why, guys? So IP EIGRP topology, because in topology table you can see for these 192 prefixes there are two paths, and the RD value and FD value is exactly same. From this neighbor also 12.2 it is learning with this metric, this FD value and RD value, and from this neighbor also FD and RD value is exactly same. This is the reason why router is performing load balancing. Done. In last class we had seen, I think, query message as well. By capturing the link we had seen the query message. So we are not going to perform the lab of query message again. Now guys, how to reduce the query message? Like let's say here there is only one path to reach in 192.168.1.0 subnet. Interface F1/0. Here I can increase the bandwidth. I can decrease the bandwidth, let's say 100 kbps. Now so IP route EIGRP. So IP route EIGRP. Now you can see these subnets are reachable via router number 2, via 12.2 from this neighbor only. And is lower path feasible successor? So IP EIGRP topology. See, tell me. Is lower path feasible successor, guys? This is second neighbor, this is first neighbor. Successor. Is this one feasible successor?
Yes, sir.
Yes. Yes, that's why you are able to see it in the topology table. In topology table, router install both successor and feasible successor. In routing table, router install only successor. In this scenario, you can perform load balancing. You can achieve load balancing. If you want to see, I can show you. Simply we can change the variance value. Router EIGRP S number 10 and say variance 2. And now see, so IP route EIGRP. So IP EIGRP topology. So IP protocol. By the way, I will come on variance later. We have to find the variance value first. What variance value I should configure here, right? But it will work only on feasible successor. For now I am going to remove it. Router EIGRP as number 10 and no variance 2. Now the topic is how to reduce the query message. How to reduce the query message. So guys, first option is adding feasible successor. Whenever a network will goes down and feasible successor is not available, or you can say whenever successor will goes down and feasible successor is not available, then router will generate query message. Purpose of query message is two things, you already know. So if you will add the feasible successor path in the topology table, then definitely router will not generate query message. Second option, summarization, right? So if you will summarize these all subnet, so guys, until and unless any one subnet will be available from the summary address, the router will not generate the query message. So these are the two options to reduce the query message. To reduce the query message. Done. Any question? No. So now let's understand.
So how we can add the non-biased path?
So there are many ways. One way, that is manipulating the bandwidth and delay. By manipulating the bandwidth and delay, you can do it.
Okay.
Just give me a minute. I want to show you the unicast update message also, and how you can perform the lab, otherwise it will be difficult. So what we can do, we can save the configuration here, or we can exit this lab. I have another topology here in GNS3. Yes, this one. See guys, here what I am going to do, I am going to configure one access control list to block the EIGRP update message. So if I will block EIGRP update message on router number 2, then router 1 will send update message to router 2, but router 2 will not generate acknowledgement. The reason router 2 will not receive the update message, will filter it with the help of ACL. So let me do it. Let me configure it. R1, R2. R1, so IP interface brief. So IP is not configured. Interface F0/0 no set. IP address 12.1.1.1 255.255.255.0. Exit interface loopback 1. If anyone want to speak, you can speak. .1.2 255.255.255.0. Exit interface loopback 1. IP address 192.168.2.1 255.255.255.0. Done. But see what will happen if I will configure access control list here. Guys, if I will configure ACL here to block EIGRP update message, right? So if I will block EIGRP message, then router will not receive hello message also, and once router will not receive hello message, it will break the neighborship. But I don't want to break EIGRP neighborship between router 1 and router 2. So what we can do, we can increase the hold on time first. I can set the maximum hold on time here, so that router should not break the neighborship. So R1, and then you can configure, you can create hub and spoke topology as well. Router EIGRP, and before configuring EIGRP, let me increase the hold on time. Router EIGRP F0/0. IP hold on time for EIGRP as number 10 is, I'm going to set maximum 65535. On router number 2 also interface F0/0. IP hold on time for EIGRP as number 10 is 65535. I've configured the maximum hold on time. Now let me enable EIGRP here. Router EIGRP ES number 10, network 192.168.1.0, and network, or let me remove this network command. For now I am only enabling EIGRP on 0/0. Only on 0/0 I have enabled the EIGRP. Do so IP EIGRP interface. Done. On router number 2 also I am going to enable EIGRP on F0/0 only. Router EIGRP as number 10, and network 12.1.1.0 0.0. Now we have EIGRP neighborship. We have EIGRP neighborship. Let me create one ACL here. Say access list. Number I am using 100 for extended ACL. I am going to deny EIGRP and source. What will be the source when router 1 will send update message to router 2? 12.1.1.1 exit interface IP address will be the source, and this is how router 2 will learn the next hop IP address for all the prefix received by router 1 from the source address in the update message, right? So either I can say source any, or I can define 12.1.1.1, right? Then destination you can define the multicast address, or you can say any source, any destination. And let me permit all rest traffic. Permit IP any. I have permit all rest traffic. Now interface F0/0 IP access group 100 and direction in. I'm going to apply it in direction. Done. Now see. Now I am going to advertise 192.168.1.0 in EIGRP. Once I will advertise this in EIGRP, what will happen, guys? What will happen? It will generate update message. Correct? It will generate, router 1 will generate
Sequence number also increase.
update message. Yes, it will increase sequence number by 1, and then it will send the update message to router 2. Do so IP EIGRP neighbor. Q count is 0, SRTT time, RTO time, sequence number, everything you can see here, right? Now router EIGRP ES number 10 and network 192.168.1.0. Wildcard mask 0.0.255. Now after running this command, check EIGRP neighborship. Q count is, that means it is waiting for acknowledgement from which neighbor? From 12.1. Like this, if there are multiple neighbor of router number 1, so Q count will increase only for this neighbor, right? And we should capture this link also here to check the message. Update message. See, it is unicast. Source IP 12.1, destination IP 12.2. Router is sending update message to this IP address. And how many unicast message it will send? It will send 16 unicast messages, right? And hold on time is, you can see, guys, long time is available. So IP EIGRP neighbor. Here Q count is 0 because this router is not waiting for the acknowledgement, right? But here Q count is 1. And do so IP EIGRP topology table. In topology table, you can see one interesting thing here for 192. Okay, wait, I will show you that also. That is stuck in active state. Done. It is sending update message. Router 2 is not receiving, so that's why router 2 is not generating acknowledgement, right? So router 2, so IP EIGRP topology. Router 2 don't have 192 subnet, right? So you can do one thing. You can wait for the neighborship break. After 16 unicast messages, it will break the neighborship. Just I have performed the lab so that you can use this technique to check, right? Now guys, I am going to remove the access control list. I will not wait. So interface F0/0 and say no access list number 1000. Now what will happen? It will send acknowledgement. Once it will send acknowledgement, Q count will become what? Q count will become what? 0.
0.
Fine. Fine. Now the second thing, second concept. Now guys, router 2 have this subnet. So IP EIGRP topology 192.168.1.0/24. Now what will happen when this prefix will goes down? When I will down the loop back 1 on router number 1, then router 1 is going to generate query message. Am I right? It will generate query message. And again, if I will apply the ACL, then router 2 will not receive query, so it will not generate what? Reply message. So what will happen if router 1 will not receive reply message? This is what if router will not receive the acknowledgement. Now try to understand what if router will not receive reply. What if router will not receive reply? So see, again first I am going to apply the ACL. This is just a technique so that you can use to check these things. IP, let me apply the ACL again. Access list number 100 direction in IP, access list, access group number 100 direction in. Done. Now let me down this loopback interface on router number 1, and here is the capturing. In the capturing you can see both routers are exchanging the hello message. That's it. Now interface loopback 1, and I am saying shutdown. It have generated the query. Here you can see the query on multicast address, and now see on router number 1. So IP EIGRP neighbor. Guys, why Q count is 1? Because it have not received the acknowledgement of query. And so IP EIGRP topology. In the topology table you can see the state from P to A. Now state is active. State for this subnet is active. Right? This is the case where a prefix is stuck in active state. Guys, the stable state is passive. All prefixes should be in passive state. That means EIGRP topology is stable. Still router 1 is sending query message but not receiving acknowledgement. So that's why you can see state is active. Passive is the stable state and active is not a stable state. Means router have not received the acknowledgement, sorry, reply message of query. Right? And why Q count is 1? Q count is 1 because of acknowledgement. So these are the two terms where interviewer is trying to manipulate the student, right? They can ask you like what will happen when Q count will increase. When router will not receive acknowledgement, what will happen? When router will not receive reply message of query, then what will happen? So guys, when router will not receive reply message of query message, it will put that prefix in active state, right? Now question is how router will recover from the active state. So Behzad, are you there? Behzad? Yes.
Yes, sir.
Yeah, tell me what will happen now. How router will recover from the active state?
I think it will wait for RTO
RTO.
time,
Why RTO time?
or
What is RTO time?
whenever let's say any router didn't get the I mean wait for specific time.
So, see, now neighborship is, guys, flapping.
Fluctuating, yes.
What is the meaning of active state, Behzad? Active state means what?
Yeah, because like you mentioned earlier, the router 1 didn't get the reply message from R2, so that's why the stats of that router prefix 192 changed to active. It's
Okay.
not passive. Yes.
See, guys, active state means router is waiting for the reply message. This means router is waiting for the reply message. Whenever any prefix bill goes down, router will generate query message to inform their neighbor that, bro, if you have learned it from me, then remove it from your table. And if you have alternate path, then send to me also, right? So whenever router 1 have sent query to router number 2, router 2 should generate reply. Reply can be negative or it can be positive. Means if this router 2 have alternate path to reach in this subnet, then definitely it will generate positive reply. If router 2 don't have any path, then it will generate negative reply. And in the query message you will see delay is what? Infinity. Delay will be what? Infinity. Means route is not available. In distance vector routing protocol we had seen that whenever router want to inform their neighbor that I don't have reachability, that time router will set delay to infinity. You can open any query message. Where is the query message? You can capture the link, you can check the query message. You will see delay is infinity. And active state means router is waiting for reply. Till when router will wait for reply message? Router will wait for 180 second. Router will wait for 180 second for the reply message. If router will not receive any reply message within 180 second, then router will break the neighborship. Now guys, what is the issue if router is breaking the neighborship? There is issue, brother. See, in the real time between router 1 and router 2, you will have lots of prefixes, right? Your topology should be always stable. How routers are going to exchange prefixes? Let's say router 1 have 100 prefix, router 2 have also 100 prefix. How they are going to exchange? With the help of update message. Both router will encapsulate, generate update message. It will include all the prefixes. So size of update message is going to be large, right? Then the IP header, Ethernet header, then they will exchange with each other. On router, both router will have route of their neighbor. You can say topology is stable. Guys, whenever router will break the neighborship, router have to again build the topology table, routing table. Means router are going to exchange hello message, null update message, main update message. Then both router will build topology table. Both router will run dual algorithm. Then they will calculate best path. They will build routing table, right? So router are actually using CPU. So that's why breaking neighborship is not good. Router should not break the neighborship. Means your EIGRP topology is not stable. This time when router will break the neighborship, and user will experience it. They will start getting slowness, packet loss. So that's why make sure whenever router is generating a query message, it should receive reply message within 180 second. Now if you have topology like this, R1 is connected with R2, R3. R2 is connected with R4, R5, R6, R7, 8, 9, 10, 11, 12, 13. In this scenario, if this X subnet will goes down, what will happen? Or here I have a subnet 10.0/8. If this subnet will goes down, what will happen, guys? Router 1 will generate query message, right, to their both neighbor, and their neighbor is not going to generate reply until and unless it will not receive reply from their neighbor. Means router is asking to their neighbor that, bro, do you have alternate path? And their neighbor is asking to their neighbor that, bro, do you have alternate path? Now this router R2 is dependent on R4 and R5. When R4 and R5 will generate reply, then router 2 will generate reply to router number 1. Right? Router 4 and router 5 are dependent on their neighbor. So guys, in this type of scenario, what can happen? It might be possible that router 1 will not receive reply within 180 seconds, because their neighbor have sent the query to their neighbor. Definitely once router 2 will receive query message, it will send the acknowledgement, but it will not send reply. It will ask to their neighbor, right? Router 4 will send acknowledgement and it will ask to their neighbor. Okay, and keep in mind that active state means router is waiting for reply. Whenever router will generate query message, or you can say whenever a prefix will goes down, router will generate query message, and it will put that prefix in active state. See what will happen. Once this prefix will goes down, first router is going to remove it from their routing table. From routing table it will remove quickly. From the topology table it will not remove, but it will change the state from passive to active, right? And now it have sent the query. Once it will receive the reply message, if reply is negative, then it will remove from topology table. If reply is positive, then it will install it in topology table. It will change state again passive. It will calculate FD value, RD value. It will install in routing table. If it will not receive reply message within 180 seconds, then the situation is called stuck in active state. Stuck in active state. The situation is called stuck in active state. And whenever you have a situation like stuck in active state, router is going to break the neighborship. So you have to avoid this situation. If router will not receive reply within 180 seconds, then router will consider it as stuck in active state. And then once it will consider their neighbor as active in a state, it will break the neighborship. If it will break the neighborship, then the entire process will happen again. Guys, EIGRP never send periodic update message because the size of update message is large. And routers are going to run dual algorithm on topology table. Lots of encapsulation, decapsulation will happen. So that's why we should avoid this state. Now, Vezad, tell me what is the solution. Tell me the solution fast.
Yes, sir. Maybe we can decrease the waiting time. I mean, lower the 180 second.
Oh, then also router will break the neighborship. In this scenario, we will not have issue. In this scenario, we will not have issue. But where issue will happen, guys? When we have scenario like this. Yes or no? when we have scenario like this. In this type of scenario, we will have issue of stuck in active state. Because here I have configured the ACL, that's why router 2 is not sending the reply message. But if ACL is not applied, then router 2 will quickly send reply message within nanosecond, microsecond, millisecond. 180 second is much time. So this is your question. What is the solution of this issue? Now the next topic. See, sometime you should also read the book, should watch the video, try to gather the information as much as you can. Then only you can learn the technology. Learning technology is not easy. These are the technology only. So guys, what we have seen here, see now EIGRP neighborship. So IP EIGRP neighbor, Q count, sequence number with this neighbor 0. This is the issue. So IP EIGRP topology, is 192 prefix there? No. Right. So if I will remove the access list from this interface F0/0, if I am saying no interface, no IP access group, now you can see. Now again it can exchange the hello message. Q count is 0. Now router 1 have the sequence number of the neighbor, Q count is 0. Now again I am going to up the loopback. So when I will up the loopback, will router 1 generate query message? Will router 1 generate query message, guys, after running no such command here? No, it will generate
Update.
update message. I can help you with one PDF. Let me share that with you. This is the solution, Behzad. Remember. Got you? Got it, Behzad?
Yes, sir.
Remember?
Yes, yes, sir.
Yes or no?
Yes, sir. Thank you.
So you can go through this PDF. You need to learn the stub router. Stub router in EIGRP is a router that is configured to prevent it from forwarding traffic between other router. This is typically used in branch offices or remote sites where the router does not need to act as a transit point. Now it might be possible that these technical terms can confuse you, like what is transit point, but it's very easy, guys. Transit point means, like, let's say I have 3 router, R1, R2, R3. Yes, Behzad, what is transit point here? Y network or Z network here? What is transit point?
I'm so sorry. I forgot.
A router
I'm so sorry.
that forward traffic between other routers. So guys, router 1 is going to forward traffic for Y subnet to router number 2. So this is what transit network. Okay, and configuring a stub router Configuring a stub router as a stub help reduce unnecessary routing update and improved network stability and efficiency. Right? You can say to reduce the number of query we can configure a stub router. Right? Don't worry, we will have the topic stub router in EIGRP. We'll see. That time I will clear this point also, like active in stuck in active state, if you will be not able to find the answer, right? Or I will send one video to you. We'll share this PDF also. If you will read it, you can learn it by yourself as well, right? Now guys, next topic is EIGRP neighborship. So how many types of neighborship are there in EIGRP? Till now we discussed dynamic neighborship. Till now what we discussed? Dynamic neighborship. Types of neighborship means dynamically two router will become neighbor. Now guys, we have one more types of neighborship in EIGRP, that is static neighborship. Dynamic neighborship and static neighborship, right? Where we need to use static neighborship.
Hello, sir.
Yes.
Sir, what is SIA query?
Yeah, that is part of SIA. What is stuck in active. Stuck in active. That is part of stuck in active only. Don't worry, we'll see. Okay. Now just focus on this point here. At the
Okay.
last, before starting the route filtering, we'll cover this topic, right? Now it might be possible that few people will not understand it. That's why I have keep it for the last, after talking about the neighborship and the next hop rule, because there only will apply the stub router, will configure the stub router, then only you can understand what is the need of a stub router. Okay, so guys, we have two types of neighborship in EIGRP. See, I have one branch office here, I have one side here, side 1, side 2. All the sides are connected with internet. In the lab, what you can do, you can connect all the sides with switch. Switch is like your internet. Why switch is like your internet, guys? Because see, if you are connecting all the sides through internet, then what will happen? You will have public IP address at each side, and all the public IP address will be reachable with each other. So either you can use one router here, the internet side, and you can configure the public IP address. After that you have to configure the NAT, those things. Or simply you can use one switch here, and you can run IP on all the router from the same subnet, and all are reachable with each other. R1, R2 and R3. Here it can be my switch. Switch is similar like internet. Through internet your all sites are connected. So for the lab you can connect all sites together with the help of switch. Now let's say this is in India, Mumbai side. This is, let's say, Delhi, and the another side somewhere, let's say Jaipur. We have three sites. Here I have some subnet 10.1.1.0/24. Here I have one subnet 20.1.1.0/24 and 30.1.1.0/24. Now guys, tell me, if I will enable EIGRP here on all the routers, right? Then router 1 will have how many neighbor? 2 neighbor. Here we will have one EIGRP neighborship. Here we will have one EIGRP neighborship, and here we will have one EIGRP neighborship. Means if Delhi and Jaipur want to communicate with each other, they can communicate directly. Any side can communicate directly. This is what? This is full mesh topology. If your all sides are communicating directly with each other, that is known as full mesh. Full mesh means all the sides are directly connected with each other. All the sides are directly connected with each other. There are two types of topology. hub and spoke, and full mesh. That you need to learn now. Hub and full mesh means all sites will communicate directly with each other. If you have 100 sites, all the sites are directly connected with each other. See guys how complex it is. To configuring routing here, if there is issue, troubleshooting can be complex because all the sites are directly connected with each other. Routing can be very complex. But it totally depends on your company requirement. The network type is full mesh or hub and spoke. Full mesh means all sites are directly connected with each other, and hub and spoke means all the branch offices are connected with headquarter. Hub and spoke. Spoke means branch office and hub means headquarter. So let's say R1 is my hub router, guys. This is hub router. This is hub router. This is spoke 1, S1 I am saying. Spoke 1 and spoke 2. Spoke 2. Now you want this, these two sides, Delhi and Jaipur, should communicate with each other via Mumbai, via headquarter. Now if you are thinking that Praful, why, what can be the reason? Reason can be anything. There are many possibility, guys. Let's say in my company there is only one firewall. I have only one firewall in headquarter, in the Mumbai office, in the data center, right? So I will not allow these two sites to communicate with each other directly because I don't have any firewall. So what I want, whenever these two sites want to communicate with each other, first they should forward traffic to data center. In data center I have firewall where I will inspect the traffic. I will check from where the traffic is coming, from where traffic is going, is this traffic allow or not, which type of traffic it is. If it is allow, then I will forward to Jaipur. If it is not allow, I will deny it, right? So requirement can be anything, but my sites branch users should be able to communicate via headquarter only, right? So this topology is called hub and spoke topology. In hub and spoke topology, all the spokes are connected with hub router, headquarter, right? So in this scenario, see, in this scenario, how you will configure the EIGRP? How you will configure the EIGRP? That's why we come up with static neighborship. Static neighborship. Here we can configure what? Static neighborship. Manually I can tell to router 1, bro, your neighbor is router 2 and router 3. I can tell to router 2, bro, your neighbor is router 1, and to router 3, bro, your neighbor is router 1. That's it. So if you want to make full mesh topology, you can configure dynamic neighborship. If you want to make hub and spoke topology, you can configure static neighborship. Now in static neighborship, what will happen? Here we will have one EIGRP neighbor, here we will have one EIGRP neighbor. So router 2 will advertise this submit to headquarter, hub router, and hub router will advertise it to router number 3. Hub router will advertise it to router number 3. Now guys, see, there is one issue. What is the issue? Issue is when router 2 will advertise it to router number 1, what will be the next hop IP address? Next hop IP address will be the IP address of this interface, exit interface. When router 1 will advertise it to router number 3, next hop IP will be their exit interface IP address. First of all, you have to disable a split horizon rule here. Otherwise, it will not advertise prefix from same interface, from the receiving interface. So it will learn prefix from Delhi. It will not advertise to Jaipur because of split horizon. So you will disable the split horizon here. Once you will disable the split horizon, router 1 will start advertising Delhi prefix to Jaipur, but it will add their own next hop IP address. But what I want, these two sides should communicate directly, but they should share routes, EIGRP prefixes through headquarter, right? Then you can disable next hop self feature on this router, right? We can disable next hop self feature on this router. I can say no IP next hop self, right? By default guys, IP next hop self command is enabled on any router. You can check interface F0/0 IP next hop self for EIGRP as number 10. What is the meaning of this command? Meaning of this command will means always share your on exit interface IP address as a next hop IP address. The source IP will become what? Next hop IP address. So we can remove this command. I can say no IP next hop self. Right, after that it will work. After that, these two sites will exchange prefixes via hub router but communicate directly with each other. Right. So how to configure it? Here I can say neighbor and then neighbor IP address 192.168.1.2, let's say. IP on hub router is 192.168.1.1. Guys, tell me, should I perform this lab or you guys can do it by yourself? 1.2, 1.3. You can do it. Simply you can disable the speed horizon here and you can disable the next hop self command. And command to configure a static neighbor is this one, router EIGRPS number 10 and the neighbor, and after that neighbor IP address. Neighbor IP address.
Sir, can you write it in the steps? What things we have to do it?
Here first form static neighborship between hub and spokes router, not between spoke to spoke. Right, then disable split horizon rule on hub router, and then disable next hop self command on hub router. After that your sites will start communicating with each other. Got it? Now guys, in this scenario try to understand, if this network bill goes down, what will happen? It will generate query message. It will generate query message. This is the reason why I have not discussed stub router there or SIA stuck in active state. Here I want to discuss that. So whenever R2 will lose this network, it will generate query message to R1, and R1 will generate query message to their neighbor, to R3. Now just think, who have advertised this subnet to router number 3? Only router number 1, and router number 1 is now generating query asking for this subnet. If there are 100 branch like this, so all the branches will receive query message. All the branches have learned this subnet 20 subnet from the hub router only, and now hub router is generating query for the same subnet. So to avoid this, here we should configure the stub. Okay, and this is the topic for tomorrow. Tomorrow we'll mainly focus on SI and stub router. After that guys, we'll see the variance, and then main topic, path manipulation, route filtering. Path manipulation and route filtering. We will have maybe 2 sessions for path manipulation and route filtering. Whatever possible way we have for the path manipulation or route filtering, we will implement all. Yes, if anyone have question, please ask. So you need to design 3 lab. 1, this one R1, R2, R3 and R4. This one second, this one, and third R1 and R2, right? Here LAN, capture this link. Okay, so make sure from before next class, tomorrow class, you will perform this lab as well. Guys, you have to sit for at least 1 hour for the lab. And one more thing, you cannot configure everything in packet tracer, so it's better to install GNS3. Better to install GNS3. Okay, now
Sir,
guys,
there is a
yeah,
I am so sorry. Sorry to interrupt you. There is a point I would like to share with you, which is about the stop router. Looks like the relay agent for the DHCP server. Whenever the DHCP server is another network, we just set the router. I mean the local router as a relay agent. That's the same with the transit router. Am I correct? Please.
yeah, that is similar like that. Yes,
Same concept, right?
not same concept, similar concept.
Thank you.
Here guys, let's say, see, so IP route EIGRP on router number 1. Okay, I have access of this topology. Let me remove this topology. I am not going to use it. Here, see, on router number 1 and on router number 4, I am going to access R1 and R4 here. Because we have 10 minutes, we can cover one topic. On router number 1, see, so IP route EIGRP. So these prefixes are best via which router? Via router number 2. Why? Because I had changed the metric on lower path, right? Now guys, we have one feature, or you can say one parameters for unequal cost load balancing in EIGRP, right? I'm not talking about the variance. Apart from the variance, we have offset list. Offset list. What is offset list? Offset list is used to perform equal cost load balancing in EIGRP, right? With the help of offset list, what you can do, you can add some metric. See, in real time, you will be not allowed to change the bandwidth and delay of physical interface, correct? So here, if you want to perform load balancing, how you can perform the load balancing, right? Two paths is there, so IP EIGRP topology, yeah, two paths are there, right? But best is via router number 2 only. So if you want to perform load balancing here between these two paths, you can with the help of offset list. What you can do, you can add some metric where on the lower path. So see, the metric from upper path is this one, metric from the upper path is this one, and metric from the lower path is this one. Right guys? So tell me how much metric I will add in upper path so that both metric will become same. We can subtract it, right? We can subtract it, calculator. Two, 5, 7, 3, 3, 1, 2, 0 minus 158720, this one. If I will add this metric over here, if I will add this metric over here, guys, what will happen? Then both metric will become same. Both metric will become same. Sorry, I think, yeah, fine. Plus 158720. See, both metric will become then same. So we can add this metric on upper path with the help of offset list. So offset list is a feature in EIGRP. With the help of offset list, we can perform equal cost load balancing, right? We can node change physical bandwidth and delay. How to configure it? See, this time router 1 is not performing load balancing, so IP route EIGRP. This is part of path manipulation only. Next class topic. But let me give you an overview. Right? So router 1 will forward traffic in this subnet via router number 2. Trace route 192.168.1.1 and source 10.1.1.1 and say numeric. Traffic is going via 12.2.2 only. I want to perform load balancing here. No problem, you can. We can. What we can do? We can include metric with existing metric with the help of offset list. So first of all, I have to specify the subnet. For which subnet you want to add metric. And to specify the subnet, we can use access control list, or I can use prefix list. We'll see what is access list, prefix list in detail later. For now, you can say access list is a feature which is used to permit and deny the traffic, as well as which is used to specify the traffic, right? Classify the traffic. Access list number 10 and then 192.168.1.0, then 0.0.0.255 wildcard mask. Access list number 10 and then action is permit. So what I did here, see, so access list. Guys, I have created one access list whose number is 10, where I have specified this prefix. Now if I want to configure any policy, anything for this subnet, I can call this access control list. If I want to configure any policy for this subnet for the user who belongs to this subnet, I can call this access control list. Like I want to add offset list with this prefix list, so I can now add this offset list with this ACL, right? So now the next command is router EIGRP S number 10 and say offset list, and then guys your access control list number. So access control list number is 10, right? Then in which direction you want to add the metric while receiving the route, or you want to add the metric while advertising the route. So I want whenever router 1 will receive this subnet, then it should add this metric. So direction is going to be in. So let me say direction in, and after that how much metric you want to add. I want to add this metric. Copy. Done. Now on which interface you want to add? On fast Ethernet 0/0. That's it. Now you can check the routing table. So IP route EIGRP. Now guys, 192.168.1.0 still we have one path only. Now you can see EIGRP neighborship is resynchronized. Now check routing table again, and you can see for this subnet now router is performing load balancing. Yes or no? So in the last class, one student had asked this question that, sir, if we are not allowed to change bandwidth and delay, then how to perform, how to change the metric? So this is the one option, offset list. Like this, we can perform load balancing for all the subnet. In access control list, I can say no access list number 10. Then I am saying access list number 10 permit. This time I am going to allow all the subnet. So it will only match first octet and second octet. Enter. Right? It will only match first octet. If value in first octet is 192, value in second octet is 168, then it will add the offset list. Now check the routing table again. So IP route EIGRP. See, for all the prefixes it is performing what? Load balancing. So IP EIGRP topology table. In the topology table, 192.168.3.0. Guys, in the topology table, what is the change? What is the changed value in topology table?
Successor.
2 number of successor. There are now 2 successor for this prefix. That's why we have 2 path in routing table, and it will perform load balancing. So if you will trace route again, now you can see traffic is going to 12.2 also and 34.4 also. So this is one way to perform path manipulation. Like this, we have multiple option. We have summarization also. Right? Now I'm going to remove the offset list, router EIGRP is number 10, and say no to this command. I'm going to say no access list number 10 also, and I'm going to remove bandwidth configuration as well from F1/0. Do so, run interface F1/0. So this command I am going to remove it. No, this. Second option, summarization. So IP route EIGRP. Now you can see again it is performing load balancing. This time the actual metric is equal from both sides. Now I want to perform load balancing. Like load balancing means, let's say for upper 3 subnet I want to use this path, and for lower 2 subnet I want to use this path. What I can do, guys, I can advertise summary address of these 3 subnet from this interface from F0/0, and summary address of these 2 subnet from this side. It's very simple. On router number 4, I can say config t interface F0/0 IP summary address. What will be the summary address of upper 3 prefix, guys? Summary address of upper 3 prefix
22
0.0 or 1.0.
1.0.
No, 0.0. Bro, you can convert
Okay,
third octet value in binary.
it's 22 now. It's 22 then 0.0. Okay, sir.
Right? Subnet mask will be what?
22.
Wildcard mask?
0.0.0.
Oh, sir,
Two.
0.03.255.
Okay, CIDR value slash value will be what? How many bits are common?
22.
22 bits are common, right? So wildcard
Right.
mask is going to be 0.0.3.255. Summary address, this one. This is the wildcard mask summary address for EIGRP. For EIGRP, ES number 10, and then this address we can specify here like this. What it's saying? Error. Support it. Here I have to specify subnet mask. Wildcard mask is not supported. So tell me the subnet mask. 255, 255.
252.
252.0.
Done. Now go to router number 1. So IP route EIGRP. Guys, these are the individual prefix as well as I have one summary address here. Right? Same thing, I need to advertise one summary address from the lower link from F1/0. Here also I can say IP summary address for EIGRPS number 10. What will be the summary address of lower 2 prefix?
4.0.
4.0. Subnet mask
255.255.4
how many bits are common? What will be CIDR? 4 and 5. Convert 4 and 5 in binary. Binary of 4 is 1 0 0. Binary of 5 is 1 0 1. How many bits are common? What happened, guys?
31.
22, sir.
21.
22.
Yes.
Sure.
I'm sorry, 23. Sorry.
23. So what will be the subnet mask?
254.
254.
254.0.
Yes.
Go to router 1. Check the routing table. Where is the summary address of lower 2 prefix? Here it is. Right? Now, now guys, see on router number 1, if I will filter the individual prefixes, these prefixes and these prefixes, then there will be only 2 route. One will be this one, this summary address, and the another one will be this one, and the another one is here. This one. So when user will ping to 192.168.1.1, it will, this destination IP address will match in this entry, right? And when user will ping to 4.1, then destination will match in this entry, right? So this is what load balancing. Now if you are thinking how you will filter the individual prefixes, there are many ways. Don't worry, we'll see that. Got it, guys? So these are the path manipulation, route filtering, the advanced topics of EIGRP. So from tomorrow we'll continue. I I have some time. At some time, that's why I've covered, give you some overview of prefix list and summarization. With the help of summarization, we can reduce the number of query as well. So query is not good thing, it's a bad thing. Because of query only router can stuck in active state.